Okay, for part A, we're trying to find out which metal is the most reactive and which one's the least reactive. So if we look at observation 1 and 3, we see that PB is willing to lose its electrons to X and to Q, making it the most reactive. And then we look at observation 2 and notice that Q is not willing to give its electrons to X, so that makes it the least reactive, leaving the middle spot for X. For problem B, we need to find the half reaction that occurs in this reaction. And if we remember fat cat, which stands for from anode to cathode, we realize that the anode is lead because in the problem it says electrons flow through the switch from the PB electrode towards the X electrode. So knowing that the electrode is lead, we look at our chart, and since E cell is cathode minus the anode, we know that cathode will be above lead, so we'd have to flip the anode. And then so we look at lead and then flip the equation, which would give us PB to PB plus 2 electrons. Now we have to determine the standard reduction potential for the half reaction that occurs at the cathode. So we're given that the E cell is 0.47, and we know that E cell equals cathode minus electrode. So cathode minus negative 0.13. And then when we solve for that, we get 0.34. And then when we look back at our chart and look for 0.34, we find out that the metal is copper.
Okay, so question D is telling you to describe what happens to the mass of each electrode as the cell operates. So up here, right here, it tells us that electrons flow through the switch from the PB electrode toward the X electrode. So since we have electrons flowing from the solution with PB into the solution with X2+, we have extra electrons in the solution that flow into the metal bar, causing it to increase in mass. So since we have electrons leaving the solution on the PB side, that means that they're getting the electrons from the bar, the PB bar, and so that one's decreasing in mass. Okay, so for letter E, question I, a student bumps the cell setup, resulting in the salt bridge losing contact with the solution in the cathode compartment. It asks you if V is equal to 0.47 or if V is equal to 0. So since there's no electron flow across the salt bridge since it's been cut off, that means that all the ions will stop flowing, causing the voltage to equal 0.
For II, the student spills a small amount of 0.5 molar sodium sulfate solution into the compartment with the lead electrode, resulting in the formation of a precipitate. Is V less than 0.47 or greater? Well, in this problem, we'd use the Nernst equation, which is E cell equals E cell standard minus RT over NF ln of PB2+ over Cu2+. So when he spills the sodium sulfate, the concentration of lead ions would go down, and if the concentration of lead ions go down, then this number gets smaller, and if this number gets smaller, if we're subtracting by a smaller number, the E cell will go up and be greater than. So the answer is greater than 0.47.
So in III, it says, after the laboratory session is over, a student leaves the switch closed. The next day, the student opens the switch and reads the voltmeter. Is the voltage less than 0.47 or is it equal to 0.47? So the voltage will be less than 0.47, which can be calculated using the Nernst equation. Since the concentration of lead will increase over time and the concentration of copper will decrease over time, it'll cause the voltage to decrease.